Namaste. We are here with the lesson of Grade 10 Science and Technology, Unit 15 Chemical Reaction. Dear students, we are discussing second part of this unit today. What did we discuss in the first part? Let's remember that. Yes, in the first part we have discussed about what is chemical reaction. And chemical reaction involves chemical change. Together with we have discussed about physical change and chemical change also. And in the chemical reaction, we have learned how to write chemical reaction in the equation form. Isn't it? Equations are symbolic equation, word equation. And while writing symbolic equation need to be balanced. To make balance from left hand side to right hand side, isn't it? And we have also discussed about the different symbols used to represent different state of reactant and product, isn't it? Dear students, we are just revising the previous lesson. Look at here. What is this? It's about a burning magnesium, isn't it? Burning magnesium is a type of, what is this? It is physical change or chemical change? There is chemical change, isn't it? Similarly, what happens? Look at it. Here is iron nail. Before, this iron nail was shiny, brilliant, isn't it? White. But after putting iron nail in open place, in the presence of moisture and air, oxygen, look at it, the color of iron nail has changed. What is the reason behind it? Do you know? Sure, this is a type of chemical change, isn't it? Here is iron rust, rusting of iron, that is, iron is oxidized, combining with oxygen in the presence of moisture, which we have discussed in previous lesson also. So, chemical reaction involves chemical change in which new product or new substance is formed which has the different physical and chemical properties, isn't it? The properties are totally new because there is chemical change. So, chemical reaction is a form of chemical change in which there is loss or gain or sharing of electron, isn't it? Between the reactants, that means between elements or compounds which are taking part as reactant or to form the new substance or product, isn't it? So, chemical reaction occur by combining, decomposing substance, either combining the substances or reactants or decomposing the reactant or by exchanging the ion between the reactants. Yes, in today's lesson we are going to discuss about this process of combining, decomposing, exchanging that involves the types of chemical reaction, isn't it? Dear students, what are the types of chemical reaction? Let's remember. There are some of the types of chemical reaction, isn't it? Mainly chemical reaction are 4 types. What are they? Combination reaction, decomposition reaction, displacement reaction, and finally acid-base reaction. What are these reactions about, isn't it? We are going to discuss thoroughly what is combination reaction. Do you know? Let's think properly. Dear students, simple activity I am going to demonstrate you. Dear students, let's enjoy one activity. Look at here. These are the 2 substances, isn't it? When these 2 substances are combined, then what will happen? Do you know? When these 2 substances are combined, look at here. A single substance is formed, look at it. A new product is formed. Yes, look at it. It can be hydrogen, it can be oxygen, then what will be? The product will be water, isn't it? If it is sodium, it is chlorine, the product will be sodium chloride, isn't it? If it is calcium and this is oxygen, the product will be calcium oxide. So, what do you understand by this? Combining 2 or more than 2 reactant to form a single product is known as combination reaction. It is also known as addition reaction. Yes, let's discuss. Then, what is combination reaction? When 2 or more than 2 reactants or product are combined to form a single product, such type of chemical reaction is called combination reaction. Suppose combination of A and B forms AB, isn't it? A single product will be there. Look at here. A plus B equal to AB. A is a reactant, B is another reactant that may be element or compound, and a product can be the compound. Yes, sodium plus chlorine, sodium chloride, isn't it? This is combining substances. And how to write in symbolic form? Look at here, sodium is represented by Na, chlorine is represented by Cl2 because it is diatomic form, and the product is sodium chloride NaCl. Is it balanced? Not balanced. Let's balance it. After balancing the equation will be like this: 2Na plus Cl2, 2NaCl. This is an example of combination reaction. It is also called addition reaction. Another example, carbon plus oxygen. What will be the product? Carbon dioxide, isn't it? When we burn any substances, any fuel, there is carbon. Carbon bonds in the presence of oxygen, then forms carbon dioxide. Reaction can be expressed in symbolic form like this: C plus O2, CO2, isn't it? This is combination reaction. Two reactant combine to form a single product, isn't it? So, is the equation balanced or not? Sure, this equation is balanced. Look at it. Dear students, let's perform one simple activity about combination reaction. What activity should you do? What happens when magnesium bonds in air and again the product is treated with water, isn't it? Do you know? I'll demonstrate you one coil. Look at it, one ring. This coil is, what is this? Do you see? This is magnesium. This is a magnesium ribbon. This is metal, isn't it? Because it is shiny. It has metallic lusters. So, it can bond to product, to give a product. What product will be there? Magnesium bonds in air. So, magnesium plus oxygen, magnesium oxide will be the product. And if that magnesium oxide, if we react with water again, then what happens? Magnesium oxide is acidic basic. It is basic because metal oxide are basic. So, it gives magnesium hydroxide, and alkali. Water soluble base is alkali. So, that activity we are going to observe here. Look at it. This is magnesium, and if this magnesium we can bond like this. We have taken a piece of magnesium ribbon in tongue, so we are going to bond it. How does it bond? Yes, it bonds like this. It bonds with the bright light, isn't it? And after bonding, what would happen? After bonding, it gives this type of product. Look at here. Here is white powder. White powder as will be produced, and if this is treated with water, then what will happen? Let's think. So, here is the reaction of this activity: magnesium plus oxygen, magnesium oxide. Now, what happens when magnesium oxide is treated with water? Then the reaction can be represented like this: 2Mg plus O2, 2MgO. Now, this MgO or magnesium oxide, if we treat or react with water, then what will happen? It will give magnesium hydroxide, another product. There is involved another combination reaction, isn't it? Compound, this is also compound, and water is also compound, isn't it? Compound plus compound, another new compound will be formed. Let's represent by chemical equation. Look at it. Magnesium oxide plus water, magnesium hydroxide. This magnesium hydroxide is a basic solution. It has basic character. It is alkali, so that it changes red litmus paper into blue color. Do you know? This is red litmus paper. This red litmus paper is converted into blue color. Why? Because the solution is alkaline, basic solution. Dear students, let's discuss about another type of reaction, decomposition reaction. Do you know what is decomposition reaction? It is just the reverse process of combination reaction. opposite of combination reaction. Decomposition means one compound is broken down to two or more than two products. Chemically, it will be broken down. So, dissociation of hydrogen peroxide with catalyst MnO2. MnO2 means manganese dioxide catalyst, which you are well familiar about the lab preparation of oxygen gas in grade 9, because we have used manganese dioxide catalyst to decompose potassium chlorate to produce potassium chloride and oxygen gas. So, this manganese dioxide is a catalyst which is used to produce oxygen gas without heating, isn't it? Look at it. It gives water plus oxygen. Hydrogen peroxide is decomposed in the presence of manganese dioxide catalyst and gives water plus oxygen. H2O2 is a hydrogen peroxide. It gives H2O plus O2. Let's balance it. Is it balanced or not? Let's check it. H2, H2 balance, but O2, here O and O2 not balanced. How to balance it? Dear students, we have to balance like this. 2H2O2 equal to 2H2O plus O2. Dear students, this activity can be performed like this. Look at here. Here is what is there? Manganese dioxide. If manganese dioxide is put here and we have to place, look at here, hydrogen peroxide, then what will happen? The reaction occurs. That means hydrogen peroxide is decomposed into oxygen gas. Yes, this is observe one experiment. So, this type of experiment can be expressed like this. Look at it. One compound, suppose AB is a compound, it is a reactant, and this reactant is broken down into A plus B product. So, how to define what is decomposition reaction? When a chemical compound is dissociated or broken down into two or more than two products, such a reaction is known as decomposition reaction. Heat, light, catalyst, pressure, etc. play the vital role to occur decomposition reaction. Some substance need heat, some substance require catalyst, some substance require light, isn't it, while taking part in the chemical reaction, isn't it? So, other example of decomposition reaction are dissociation of water into hydrogen and oxygen by electrolysis process. What is required here? Electricity is needed, isn't it? So, water is decomposed into hydrogen and oxygen. We can write balance equation like this: 2H2O equal to 2H2 plus O2, which we have already discussed, isn't it? Here is electrolysis process. Look at it. Here is battery, electricity is supplied here, and here are anode and cathode. So, here is in one test tube or gas jar, hydrogen is collected, another test tube or gas jar, oxygen is collected, isn't it? This is the process of electrolysis, which you might have observed in your science lab. You might have involved in the practical activities also. Similarly, calcium carbonate is dissociated on heating. Calcium carbonate, that is limestone. When limestone or calcium carbonate is dissociated, then what will happen? It gives calcium oxide and carbon dioxide. Calcium oxide is a quick lime and carbon dioxide gas is also produced. How to write in balance equation? We can write like this: CaCO3, when heated, it gives CaO plus CO2. Heat is necessary in this reaction. It should be heated. Similarly, another compound is zinc. Look at it, zinc carbonate. Zinc carbonate is heated, and what will happen? Zinc oxide plus carbon dioxide is released as product. Similarly, on this zinc carbonate we can express in this symbolic diagram also. This is ZnCO3, this is ZnO, and this is CO2, isn't it? What type of reaction are these? These are decomposition reaction. These are dissociation reaction. Do you know what will happen reverse of this reaction? Look at it. When hydrogen plus oxygen combine, it gives water, isn't it? So, it is the opposite of combination reaction. But when water decomposes, it gives hydrogen and oxygen. So this is just the reverse process. Now we are going to discuss about displacement reaction. Dear students, what is displacement reaction? What does it involve? Look at it. One diagram. Here is AB compound, isn't it? AB is a compound. C is another substance. It will be element, isn't it? Maybe metal or non-metal or any element, isn't it? But here, look at here, in the AB and C, the reaction will be like this. A is released, A is displaced. The place of A is substituted by B. So instead of AB, there is BC, isn't it? BC, understood? B and C are combined and A is displaced. So here is only one substance or a radical or ion is displaced. And some of the chemical reaction, look at here, in the product, A, B and CD are the product. Here are the two substances, two elements are combined there. A and B are the two elements or two radicals. C and D are the two elements or the radicals. So there is displacement, look at here. Instead of AB and CD, the ion are exchanged. There is exchange of ion, exchange of substances, and the product will be, instead of AB, look at here, there will be AD plus, instead of CD there is CB. Yes, this type of reaction is called displacement reaction. Dear student, then what is displacement reaction? The chemical reaction in which an atom or radical or ion of a reactant is displaced or replaced by the atom or radical of another reactant to form a new product, isn't it, which is represented clearly by this first example. So this type of reaction is called displacement reaction. So according to this process, according to this example, do you know what are the type of displacement reaction then? Is it only one type or two types? This is one type, this is another type. Then what are they called? They are called single displacement reaction and double displacement reaction. The first example is single displacement reaction, because there is only one atom, only one radical or ion is displaced, look at it, isn't it? But here in second example, both the radicals are displaced. So this type of reaction is known as double displacement reaction. So let's discuss about single displacement reaction and some of the example of it. Dear student, single displacement reaction, to observe, let's perform one activity, one simple activity. And dear students, look at here. Here is one test tube and here is one metal. Which metal is it? This is magnesium metal, isn't it? Magnesium metal. And we are going to perform one activity. Look at here. This magnesium metal is reacted with one substance. What is this? This is acid. Here is written HCl. Dear student, HCl means it is hydrochloric acid. So when magnesium reacts with hydrochloric acid, dear student, did you observe the reaction? Is reaction taking place? Sure, reaction is taking place between metal and acid. Which metal is there? Magnesium metal. And magnesium plus hydrochloric acid. Magnesium chloride plus hydrogen gas. Hydrogen gas is released there, isn't it? Hydrogen gas can be released and it gives pop sound by burning the hydrogen gas if we perform these activities. Similarly, this is another metal. What is this? Zinc. Granulated zinc also can be reacted with acid to give zinc chloride and hydrogen gas. So this type of reaction is single displacement reaction. In this activity, we observe the reaction between magnesium and dilute hydrochloric acid, and we can write chemical reaction like this in the equation form: magnesium plus hydrochloric acid. What happens? Magnesium chloride plus hydrogen. It is the product. So Mg plus 2HCl, MgCl2 plus H2. This is balance equation for this activity. Dear student, how displacement reaction occur here? Look at it. Magnesium possesses positive charge, isn't it? Because its valence is 2, it loses 2 electrons. So magnesium positive ion, and in HCl or hydrochloric acid, hydrogen gives positive ion and chlorine gives negative ion. Look at it. How displacement occur here? Magnesium displaces hydrogen, isn't it? So place of hydrogen is taken by magnesium and the product will be MgCl2. That means Mg plus plus and 2Cl minus, isn't it? Look at it. And hydrogen is displaced so that hydrogen gas can be released in this reaction. So here is only one ion. That means positive ion is displaced by another positive ion, or metal displaces hydrogen from acid because hydrogen gives positive, metal gives positive. Now, how to define single displacement reaction then? We can define single displacement reaction like this. The chemical reaction in which only one atom or radical or ion of a reactant is displaced by another atom or radical or ion of reactant, isn't it, which possesses same charge, isn't it? Suppose positive is displaced by positive. Similarly, negative also can be displaced by negative charge to form a new product. This is called single displacement reaction. Look at it. Here is a substance. This is a metal or one electropositive or negative radical which is displaced from another, isn't it? So here is one displaced, another is combined. This can be represented by animation also. In single displacement reaction, there is the displacement of a negative ion also. Negative radical displaces another negative radical. Look at it. In the reaction between chlorine and potassium bromide, bromide ion, which is negative ion, is displaced by chloride ion, which is also negative ion. So chlorine plus potassium bromide. Remember, we have already discussed about chemical reactivity of the elements in group 7. Chlorine, chlorine, bromine, iodine. Which is most reactive? Chlorine is reactive. So between chlorine and bromine, which is most reactive? Sure, chlorine is reactive. So chlorine displaces bromine or bromide. Look at it. So the product will be potassium chloride and bromine. The reaction can be represented like this. Chlorine is diatomic form, so we write Cl2 plus KBr, potassium bromide KBr. It gives potassium chloride plus bromine. So fluorine, chlorine, bromine, iodine, these are halogen group. Group 7A elements or group 17, which are expressed in diatomic form, which we have already discussed in previous lesson. So let's balance the equation. Equation can be balanced like this. Look at here. Cl2 plus 2 KBr, K2 KCl plus Br2. Do you know what are the charges? Charge there, isn't it? Yes, chlorine and bromine both are negative charge. So negative ion is displaced by another negative. Now let's discuss about the double displacement reaction. Yes, what is double displacement reaction? Let's see some of the example. What happens when silver nitrate is treated with sodium chloride? Remember, silver nitrate is treated with sodium chloride. Look at here. Sodium chloride plus silver nitrate. What will happen? Silver chloride plus sodium nitrate. We can express it in symbolic form, NaCl plus AgNO3. It gives what product? AgCl plus NaNO3. Dear students, here look at it how the ions are displace or replace. Look at this is a silver chloride which is stored in a dark colored bottle because silver chloride is affected by light, isn't it? So that it need to be protected from the light, so it is stored here like this. So ion exchange process occurred there. Look at here, sodium is positive ion, chlorine is negative ion. Silver is positive and nitrate is negative ion. So how double displacement occur here? Sodium displaces Ag and Cl displaces NO3, isn't it? Positive displaces another positive ion, negative ion also displaces another negative ion. So the product will be AgCl and NaNO3. Look at here. Instead of NaCl, there will be AgCl. Instead of AgNO3, there can be NaNO3. So both the ion are displaced or replaced. And in another meaning, there is ion exchange process. So look at it. This is displacement which is demonstrated in the diagram also by arrow. Yes, which ion is displaced? We can express it. The chemical reaction in which both the atom or ion of a reactant are displaced or replaced by both the atoms or ion of another reactant to form a new product. Such type of reaction is called double displacement reaction. This can be represented by this also. AB and CD are exchanged. Look at here. Instead of AB, there is AD. Instead of CD, there is CB. Yes, reactant and product are like this. Yes, in the double displacement reaction, what happens when barium chloride is reacted with silver nitrate? Let's discuss another reaction, barium chloride and silver nitrate. Dear students, barium chloride and silver nitrate are the reactant and the product is silver chloride and barium nitrate. In this reaction, there involves double displacement reaction. How? Look at here. BaCl2, it is barium chloride, plus NaNO3, silver nitrate, involves NaCl plus BaNO3 whole bracket 2. And here is also ion exchange process. The barium chloride is like this and sodium nitrate is like this. These two reactants undergo chemical reaction and the new product will be sodium chloride and barium nitrate. Dear students, the equation is not balanced because look at here, nitrate NO3 is double here, which is not balanced, chlorine is double here. So let's balance like this, BaCl2 plus 2NaNO3 equal to 2NaCl plus BaNO3 whole bracket 2. This is the balance equation for this reaction. In this reaction also, barium is positive, chlorine is negative. Sodium is positive and nitrate is negative ion. So positive ion replaces positive ion. Barium displaces sodium and chlorine displaces nitrate ion. So the product will be like this, which is formed by ion exchange process. After reaction between lead nitrate and potassium iodide, look at it. Lead nitrate and potassium iodide, when they react, there is a reaction, it gives what? Potassium nitrate and lead iodide. Look at here, lead iodide and potassium nitrate, the equation is not balanced. Look at it, nitrate is double here, but nitrate is single, iodine is single here and iodine is double. So how to balance it? Yes, let's balance it. The equation is balanced like this, PbNO3 whole 2 plus 2Ki, here is 2, we have to balance it, 2KNO3 plus PbI2. Yes, so this reaction involves what type of reaction? Double displacement reaction. Dear students, let's discuss about another type of reaction. What reaction? What type of reaction is it? Acid-base reaction. Acid-base reaction is also called neutralization reaction. Look at it, it involves acid plus base. There will be formation of salt plus water isn't it? This reactant are acid and base, and the product is salt and water. One example is HCl means, which acid is this? Hydrochloric acid, and NaOH means sodium hydroxide base. So the product will be sodium chloride plus water. Let's see the equation. Hydrochloric acid plus sodium hydroxide will react together to form the sodium chloride is a salt plus water. Here acid and base are neutralized. The properties of acid and base are totally neutralized, and the new product salt and water are formed. We can express the symbolic equation like this: HCl plus NaOH, NaCl plus H2O. Look at here. So the reaction between hydrochloric acid and sodium hydroxide can occur like this. So how to define this reaction? This reaction we can define like this: when acid and base react together to give salt and water by neutralizing the properties of both acid and base or both reactants, such chemical reaction is known as acid-base reaction. In another word, it is also called neutralization reaction. Let's see another example: reaction between hydrochloric acid and sodium or potassium hydroxide. You can use any hydroxide, sodium hydroxide or potassium hydroxide. You can make the reaction like this: HCl plus NaOH. What will be the result? Result will be NaCl plus H2O, isn't it? Hydrochloric acid plus sodium hydroxide, sodium chloride plus water. Similarly, hydrochloric acid plus potassium hydroxide, KOH. We can use potassium hydroxide also. Then the product will be potassium chloride plus water. Look at it. Are these both reaction balanced? Let's check it. Yes, the reaction are already balanced. So acid plus base, salt plus water. Sodium chloride is also salt, potassium chloride is also salt. Similarly, instead of hydrochloric acid, we can use sulfuric acid also, isn't it? Look at it. Here is reaction between sulfuric acid and sodium hydroxide, and the result will be sodium sulfate plus water. And look at it. Here is hydrochloric acid, here is sodium hydroxide, and the reaction is like this. And dear students, we can express this equation in symbolic form. Look at it: H2SO4 plus NaOH, Na2SO4 plus H2O. After balancing equation, we can write like this: 2NaOH, H2SO4 plus 2NaOH, Na2SO4 plus 2H2O. Reaction between nitric acid and potassium hydroxide, also acid-base reaction. Another acid is nitric acid. Do you know formula of nitric acid? Sure. Its formula is HNO3. So nitric acid plus potassium hydroxide, it is base. It gives potassium nitrate plus water. How to write in balance equation? We can write like this: nitric acid HNO3 plus potassium hydroxide KOH. It gives potassium nitrate KNO3 plus H2O. Yes, this is balance equation. This is acid-base reactions. Acid plus base, salt plus water. Dear students, we have discussed different type of chemical reaction in today's lesson. Now let's engage in one activity. Yes, I am going to ask you some multiple choice questions. The first question is like this: which of the following is correct and balanced equation for the reaction when hydrogen bonds in air? Remember, hydrogen bonds in air. Hydrogen plus what is in air? Oxygen. What happens when hydrogen bonds in with oxygen? It produces water. So we have to find the correct equation here. First answer is H2 plus O2, H2O2. Is it correct? Or second one is 2H2 plus O2, 2H2O. Is it correct? Third one is 2H2 plus O2, 2H2O2. Is it correct? Or the last one is 2H2 plus O2, 2HO2. Please find the correct answer. Yes, you must have found. Let's check it. Yes, 2H2 plus O2, 2H2O is the correct and balanced equation for the reaction. Now, let's discuss question number 2. Question number 2 is like this. Which of the following is correct in the place of X in the reaction? H2SO4 plus X is equal to Na2SO4 plus 2H2O. Dear students, in the reactant there is sulfuric acid H2SO4, and in place of X we have to find which substance should be there, and the product will be sodium sulfate Na2SO4 and H2O. Remember, that must be, I think, acid plus base should be there, isn't it? Did you find which one will be the correct? Is it Na2S, Na2O2, or Na2O, or NaOH? I think you must have found the correct answer. Let's check it. Sure, there should be NaOH, means sulfuric acid plus sodium hydroxide equal to sodium sulfate plus water. This is the correct equation. Now, let's discuss question number 3. Question number 3 is like this. Which of the following reaction occurs when sodium chloride is treated with silver nitrate? Remember, sodium chloride plus silver nitrate. What type of reaction will be there? Is it combination reaction, or decomposition reaction, or single displacement reaction, or double displacement reaction? What type of reaction does it involve? Did you find? Sure, you must have found the correct answer. Let's check it. Definitely, it is double displacement reaction. Dear students, we have discussed different type of chemical reaction. What are the different type of chemical reactions? There are 4 types: combination reaction, decomposition reaction, displacement reaction, and acid-base reaction. Under displacement reaction, we have discussed so many examples about single displacement reaction and double displacement reaction. You please try to complete exercise given in your lessons, given in your chapters, and you try to practice more and more chemical reaction of it. Today's lesson is over. Its remaining part we will discuss in the coming class. Thank you. Namaste.